This is really exciting for us. We had hoped to have the field days during the year, but it's been such a crazy year with COVID and everything going on that we weren't able to. So we've replaced it with this digital field day, and we'll be looking to do some on the actual field this coming year. So please stay tuned for that. So quick overview on the field that have been working on. This is 7+ acres on the Connecticut River. It's a terrace just above the river. This was our third growing season, so we're really pretty early on, just getting all of our systems established. It's leased land, and with a long-term lease, 20 years with the rights to renew. And it's also certified, at least the nuts, trees, and the fruit is certified at this point. And Martin could talk about that with the chickens as well. So the chestnuts are on north-south rows. We'll kind of zoom in on that in a little bit. There's about 320 trees planted at this point. And then in between the tree rows is alley cropping with small fruit and rotational chicken grazing. And we've had some of our preliminary harvest this year, which has been pretty exciting. And so here's a little bit on the ground. You can see the trees are really growing pretty well, coming out of the tree tubes, which are there for protection. And they've got growth is somewhere for a lot of the trees between 6 and 10 feet. There's a pretty good herbaceous ground cover of mixed species. In this picture on the left, you can see there's actually a lot of diversity, and some of the legacy from it being a row cropped field with garlic and lemon balm and mint, in addition to a lot of other meadow kinds of species. So the SARE grant that is helping to fund this has been really important to help keep ourselves going and ability to do a lot of things we're doing. And the summary of what we're trying to do is implementing a range of regenerative agriculture practices in this perennial cropping and agroforestry system, and then to measure the changes in soil health and carbon sequestration with various quantitative and qualitative measurements, which we're going to talk about. And the graphic on the left is what we're using to kind of visualize what, in a broad kind of way, what that looks like with the alley cropping on the north, silvopasture, rotation grazing on the south, and the field bounded by the river and the riparian forest to the west, and a intermittent stream to the east. And so just going to back up for a moment here and talk a little bit about the chestnuts that we have planted. These are Chinese and Chinese hybrids being grown as an agricultural crop. It's not about American chestnuts, which is a really great project to bring back the American chestnuts, but this is really agricultural growing. And in the US, we're the only country that can grow chestnuts that doesn't have or has a very small commercial chestnut industry that's just getting going. Right now, 90% approximately of our annual consumption is imported. So there's a huge opportunity to grow what is even eaten in this country here. There's about 4,000 acres of chestnut production in the US. And that's a approximate because there's a lot of acreage going in. And shout out to Dr. Sandra Agnagnestakis, who is here on the line. Thanks, welcome. And it's really her work and a lot of other people's whose shoulders we stand on to do this kind of project and growing and developing the chestnut industry. And her work at the Connecticut Ag experimentation has been super foundational. And just a quick review of the chestnuts' needs for production is they grow in climate zone 4 through 8. They do well in hot summers. The soil needs to be well drained, and they can handle tough conditions. The soil needs to be acidic, definitely below 7 and 5.5 to 6.5 range. Flat to moderately steep is ideal, or what we'd be looking for. And they definitely need full sun, and definitely need to be considering access for equipment and harvest and being able to get into a field. So we're going to go through the different parts of the project, from the trees, the chickens. We'll talk about the soil testing at the end and what we've been learning. So the intercropping of small fruit in the alleys consists primarily right now of elderberry, aronia, and black currant. And the reason that we picked those is that they're pretty easy to grow, pretty stable, and tolerant of the conditions that we have. And the markets are also really well developed to in some cases, like elderberry, very solid, and case of aronia and black currant still in development. And so I'm going to try and see if this video will load, and we can kind of have a little bit of a tour through the field. All right. It's maybe trying. So what we're seeing here is the layout of the rows with the trees in tree tubes, north, south. And then on the left here, these rows are 20 feet apart. So it's a little bit of a denser planting with the chicken rotation areas that Martin's going to talk about in a moment. And in between those rows, like right here, this is actually persimmons. And then further to the north are rows of elderberry, aronia, and the black currant. And so see if we can skip ahead. This video, I think, is going to cause a problem. Oh, there it goes. So here you can see on the left rows of aronia with our wood chip mulching underneath. Those are white flower heads, midsummer, the aronia flowering, and then the berries ripening on the bush here, and then the elderberry in flower. And so we've got 2 rows in between the 40-foot wide chestnut rows, 2 rows of small fruit that are coming into production in year 2, and then probably anticipating being able to grow them for 10 to 15 years as the canopies are closing in by the chestnuts, and then we segue the field into the other uses, either more grazing or different kinds of crops underneath. And so I mentioned first harvest this year, and so that's pretty exciting. And we're the chestnuts on the left, aronia in the center, and elderberry on the right. And so we're pretty happy that that things are moving along, getting established pretty well. All right, so I'll pass it off to you, Martin.
Okay, I have successfully remembered to unmute my microphone. So hi, I'm Martin Anderton. I am the owner of Homestead Habitats, and I'm the chicken manager at the farm. And this year we successfully harvested 1,700 chickens for meat off of the southern half of Big River Chestnut's orchard. So we used about roughly 3.5 acres, assuming that we cut the field in half, but rough. So just my first slide is just chicks in their movable brooder with my son Jack, and then some chicks that have just been put out on pasture with some dandelions. And then as they mature, they turn into the larger chickens there on the right of the screen. Again, with the boys, just a nice example of how well cared for they were, very unafraid and very happy. Next. So the goals of having chickens in the orchard were to practice silvopasture. Most of you probably know silvopasture is the incorporation of grazed livestock in agroforestry. Not strictly agroforestry, but forestry in general. Then to create a alternative income stream for the farm, a healthy natural method of fertilizer, diversification of products from the farm, natural pest and disease management, and light tillage. Next.
Hold on a second. There we go.
So for pest control, chickens naturally consume grubs, mites, beetles, things that would harm the trees, and as we found out, voles. Jono will probably cover later the issue that we've been having with voles. I found out the other day that on average in Massachusetts, there are several thousand voles per acre in Massachusetts. So it's a big problem, and chickens eat them. What do you know? This is actually one of my chickens from this summer eating a vole. Fungi and bacteria are aided when the bacteria and, just bacteria, beneficial microbes in the manure are dropped directly on the field. They simply help balance the microbes that are already there in a positive way, helping to eliminate harmful ones. Next. So the manure is an awesome fertilizer. You can get a lot of macro and micronutrients from chicken manure. It's interesting to note that what you get in your nutrients you get from your chicken manure is actually influenced by what is in your chicken feed. So you can sometimes adjust that to control what's going on to your field. The benefits of direct application is that, again, also with the beneficial microbes and bacteria, when you're composting in a pile, you often lose nutrients to evaporation and leaching into the area around it. The microbes being deposited directly on the field help with increased decomposition speed of organic material, which in turn helps with your nutrient holding capacity. You want more organic material to hold nutrients in the field. And next, needed a better segue for that one. Sorry. So chickens, this summer were fed Green Mountain organic broiler crumbles. Again, the ingredients can directly affect the nutrients that are going into the field. For anybody that is interested, you can go back later and look at the ingredients that are in the feed here. I just posted a list for anybody who is curious about what might be going on to a field. Next. Shallow tillage. The chickens naturally scratch through the soil, looking for bugs and insects. As they're doing that, they're mixing in organic materials that are on the surface, getting them in more direct contact with the soil, laying down dead grass so that it can decompose more quickly, and loosening, breaking up organic stuff, larger chunks. So this in turn helps reduce runoff. Next. Our practices, we practiced rotational grazing and pasture management. We fed organic feed. Even though I was not organic certified, it just became too pricey. We used fencing and guardian geese for predator protection, which I will get into next. Jono, next.
Okay. Do you want to explain how the you move the protectors through that area?
It's going to in the next slide.
Awesome.
Or, well, maybe not that slide specifically. So the rotational grazing pattern, I moved the houses between the rows of trees. They were inside of fencing that allowed me to move each house one day or every day for 7 days. So I only had to move the fence itself every 7 days, once a week. We ran 6 batches of 300 through the pasture. One batch was only 200. And the rotations were such that I only had chickens on a particular area of the pasture every 3 months, so that the area had 3 months to rest to reduce the bacterial load that could harm the chickens in the future. On the right is an example of my grazing plan. On the left is, on the left is the grazing plan. On the right is the grazing plan in action. Next.
Okay.
So the predator protection came in 3 forms. I had electronet fencing that went around the houses. This was important because my houses were open-sided. The chickens were never actually confined. So at night they needed something to keep out the coyotes and foxes. That was the electronet fencing. But then there was the aerial predators, hawks and owls. In the left-hand picture is a picture of what we called the circus tent. It's a pole set up in the middle of the pasture with, in our case, small thin ropes to create a net over the pasture. And then I also tried guardian geese. I concluded that our particular variety of goose, unfortunately, was not the right kind, because I have some Chinese geese here at home that are protecting my laying flock wonderfully. And the geese that were with the meat chickens just were not effective. I lost a lot of chickens to hawks. Next. Forage and pasture management.
That's for me to talk to.
Sorry. So forage and pasture management, we tried to mow 1 or 2 weeks in advance of chickens being on the section of pasture. This allowed regrowth that is much more nutrient dense and easier for the chickens to eat and digest. The tree rows were left with a 3-foot wide swath of unmowed vegetation. This provided sun protection, wind protection, created a visual barrier from ground-based predators, also provided a place for the chickens to go to get away from hawks again, and also provided a more diverse source of forage. Things would colonize underneath of taller plants that weren't necessarily out with the shorter mown plants. We tried to encourage diverse plant varieties and forage by planting shrubs and integrating native and existing vegetation with cover crops, rotting organic materials left in the field to encourage insects, and chickens like rotten stuff. Next. Takeaways, so we did observe some increased health of the plants where the chickens had been. Such as lusher foliage, more greenery, accelerated growth. According to, so the meat that I raised is sold locally, and customer feedback, I'm proud to say, was very positive, that in that the chicken I produced there was much better quality, better flavor, and better texture. The texture of the meat is different when it's pastured. Quality of life for the chickens could be improved. I did conclude that I probably had too high a stocking density. This was made evident by high amounts of manure on the field. Ideally, we would not have any manure being washed away, potentially getting into the river or water systems. It should all be held right there in the soil without leaching. And I may have exceeded that, unfortunately. I definitely could have had another shelter or fewer chickens per shelter. I had hoped that there would be more, that they would be able to shelter in the foliage more from the large trees, plants, but that just wasn't the case. And, lowered stocking density increased their access to diverse forage and would in that way reduce the amount of feed that they consume. So as I also concluded that as there's more organic material put into the soil each year, the nutrient holding capacity will increase. So it's my belief that as time goes on, I will actually be able to put more chickens or animals onto a particular area without worrying about runoff. So every type of poultry, every type of animal, even the difference between chickens and turkey, there are different nutrients that are deposited onto the field and different bacteria and microbes. So increasing the types of birds that we have will increase the nutrients that are being put on the field. So I want to switch or also add turkey next year. The advantages to turkey being that they're natives. Chickens are not native to here and require a high input of grain, which has to be brought in from somewhere else. Turkey could actually eat chestnuts, acorns, and are more likely to consume the forage that's there and anyway, more readily than chickens. So definitely want to encourage the use of turkey over chickens, but the disadvantage of turkey is that they don't produce eggs the way chicken laying hens do. So, all right, that's my presentation. If you got any questions, are we doing questions right now?
Martin, I think what we'll do, we'll take a couple minutes. So Genevieve is tracking questions that are in the chat, or if I'll leave it to you, Genevieve, to facilitate questions.
Yeah, sure. So there are a couple of questions here, two from Cynthia and one from Kate. And I think, Cynthia, one of yours perhaps was from Jono's intro, but Cynthia asked, do you find the harvesting and cleaning of elderberry and aronia labor intensive? And I know this isn't happening yet, but does that affect, or would that affect the selling price? And how would you cover labor for when that comes into play in the system?
It's a really good question. We won't get into it too much, but I am looking at in particular elderberry destemmer that the I think it's called the Midwest Elderberry Collective or Collaborative has developed. So there's some kind of small to medium scale equipment to try and increase the speed in the elderberry processing and aronia as well. So I think we'd like to do something where our site could be a place where there's some aggregation, where some other small to medium scale growers can bring their berries, and there's some equipment, and then there could be some shared equipment, some shared that kind of processing, possibly value added, or at least shared marketing. So that's all to be explored in the next few years.
Great. And another from Cynthia. I think this is in part in response to Martin about the nutrient management with the potential overstocking of chickens. I think this is what I'm understanding. And maybe Cynthia, you can elaborate if I'm getting this wrong, but could you consider nutrient infiltration at the edge of the field near the river?
Yes. So there is a law dictating that I need to remain 50 feet away from water sources with livestock. That being said, when you look at pasture with a lot of diverse plant growth and root masses, you can see where a less healthy pasture, less diverse pasture would be endangering the waterways a lot more than what's at Big River chestnuts right now. And as I said before, as the diversity increases, that danger will go down. So yes, my chickens were 50 feet away from water sources. I would actually also like to point out, I forgot one key thing around the predator control. My goal is to not eliminate predators in the field. It's my belief that we're trying to create a diverse system. A diverse system includes predators, as is the case with the voles. We need something to eat voles. It's part of why sorry. I had a timer going. But that's why I was fencing immediately around the houses rather than fencing the whole pasture, because I still wanted predators to be able to get in around those fences. And the goal would be to provide them things to eat outside of the fences so that they are not encouraged to come through the fences and eat the chickens instead. Just wanted to add that. Thank you.
Great. And Martin, just one more quick question from Kate. Did the circus tent come all the way down to the ground, and was it time consuming to move?
The circus tent was time consuming to move. I did discontinue that after I got the geese. What I did was I tied it to the fence itself. So the fence posts were about 4 feet high. The strands came down to each post around the houses. If you had a stationary fence, you could actually do this, with a stationary post and, just have a permanent set of wires or something going around the perimeter of your pasture. My pasture was a little bit too big, I think, to do that. It's something worth experimenting with, though.
Great. Okay, well, I think we'll move on, and we'll aim to have some more question time at the end. And so thanks, Martin.
All right, thank you, Jana.
So we're going to talk some more about some of the other practices in addition to the chicken rotation through the field. This is kind of the suite of different practices that we're using for the grant. For these 3 years of the grant, we are grazing, Martin's rotating the chickens on the south side of the field only. We're seeing if we could tease out differences in the soil, the different soil characteristics from that differentiation north to south, 2 sides of the field with very similar characteristics. But the rest of these practices are being done across the field. And so the soil amendments that we've been adding to bring the minerals into better balance and deal with deficiencies. There's been a few deficiencies, not a lot, and some micronutrients that are low. So we've been adding back micronutrients. We've added in, brought in calcium through gypsum and sulfur, both of those. And we've been using azomite. And so also with some different biological amendments, which I'll show next. And the fertigation, we've been both applying those dry amendments around the trees and with a growing circle as the trees get larger, widening the circle of where those different mineral amendments and biological amendments have been going. And then we've also been doing fertigation, which is foliar feed, irrigation, on the trees, aiming for about every 10 to 14 days, 5 to 7 times a year. This is the setup that we had last year on the left there, which is the tank being pulled by the truck. Now it's a tote, a slightly larger tote being pulled by a tractor. But you can see here in front of the tank on the trailer is a little pump setup. And so that pumps to the hose. And so one person can operate this by sitting in the truck or on the tractor and spraying each tree, going down the rows, spraying a foliar feed on the trees and then around the soil around as well. And so everything that's dripping off is going down into the soil as well. So it's a kind of a nice sprayer fertigation setup. And on the right bottom there is a sprayer set up on loan from the Side Hill Farm folks. Shout out to them for letting us trial this. It's a tote with the 3-point hitch on the left, and then the liquid amendments inside the tank, and then the sprayer on the back there that goes 40 to 50 feet wide, so it can cover quite a bit of the field and quite a bit of those alleys between the trees. And so as we segue from doing these amendments primarily around the trees and the tree rows to the whole field, that's the kind of setup that we'd be looking for. And so some of the biological inoculants that we've been doing, I've been really trying to do a diversity, and Caro is going to get into some of the biological indicators and showing some of the deficiencies and the lack of real soil biology currently. And so on the left, we've been collecting puffballs from different forest areas off of logs, and to bring in those mycelium inoculants and doing, basically making a liquid to spread those spores around the field and try and get them down into the soil and in contact with the roots. On the top center there is Ben Goldberg, who's a worm grower of extraordinaire, and we've been making worm tea and spreading the worm tea on the field and all the biology that's within that, the vermicompost. And then on the bottom and then the right is a group of kids who came to help us deliver the compost tea that we had brewed up to the trees. And so they had a great field day. It was a whole group of kids from different families that are all potted together during the virus, during COVID. And they came out and helped us bring out the compost tea and spread it around under every tree to sort of increase really to try and stimulate that biology through these different kinds of practices. So in addition, I'm not sure if this video will work. So here's what Martin was alluding to, which is basically our short rotation coppice, where we've allowed the growth of the herbaceous and woody vegetation. There's a box elder and there's other saplings in addition to the goldenrod. And then sporadically, kind of in pulsed way, we mow through that and end up with this chopped up woody material on the ground. And so that's meant to be a stimulant for the fungi and the whole soil food web to inoculate and kind of get that organic matter going and get the whole cycle of soil biology, as well as covering the ground, providing place, as Martin said, for bugs to reside, and the chickens can come in and forage. And so we're not doing that across the whole field at any one time. You can kind of see on the right where we've done a row of it, but we're also leaving some areas both for cover for the chickens, for pollinator support, for to let those plants grow up to be of a size where we want to chop it back. So so these are ways in which we're bringing in woody material, in addition to wood chips and laying down wood chips underneath the trees. And then as Martin was talking about, we did have some explosions of voles in the field. And so that's been a problem. And we've actually pulled back from doing wood chips around the trees, or at least in any kind of thick ring around the trees, but a much thinner layer, and nothing that the voles would then be able to use for habitat and nesting in, to sort of attract them by the trees, trying to keep them further away. So pretty excited about that short rotation coppice. Hold on a second here. So then we're doing a kind of a connected series of different practices this is meant to lead up to cover cropping. So the subsoiler addresses the compacted layers that we found in the field that are just below the surface, probably from the previous agricultural uses over generations. And so the subsoiler is, in this case, a single tine, though there are subsoilers where you can have multiple tines going down, and you can kind of see the shoe that goes down into the soil. So it's going to go down about 15 to 18 inches, and it's a long, thin piece of metal here. Can't see it from the other direction, but it's a very thin piece of metal. And so it's just going to rip a small furrow through the soil, leaving a little bit of a ridge. This is a pretty inexpensive subsoiler, really inexpensive. It's already needed a repair, but it's enough to get us started and get us trialing, and then we can upgrade from here. And so on the left, you can see ripping through some herbaceous material. And then on the right is an area where the chickens had been taken off in the last week, in our sort of late summer, early fall. And then the goal is to come and sow those areas with a cover crop. And so before we did that, after subsoiling, we came through with a disc harrow, and just to get down, break up that top sod layer a little bit, 3 to 4 inches, get some open dirt, and allow the cover crop to get established. And so you can see here, and we're doing it again, just like the mowing and the vegetation management, not doing it everywhere, but hitting certain zones and between the tree rows, but not within the rows. So there's still a lot of vegetation, a lot of diversity of different zones within the field. And that's kind of what we're aiming for. There's not one simplified system. And so here's what we're doing with cover crop this year. Pretty decently diverse mix of 2 different kinds of clover, yellow pea, so a few different legumes, the daikon forage radish to get a big root down in there for the compaction, to deal with the compaction again, plus winter wheat, oats, and rye, and spreading it on the lower left there, doing that pretty much. We did the whole, all the areas that was probably half of the 7 acres that we sowed in cover crop, and it established pretty well. This is a zone with pretty thick daikon radish establishment. Okay, so I think let's stop here and just to see if there's any questions, anything anybody wants to shout out. I can't see the chat from here, but Genevieve, have there been any questions?
No questions in the chat for this section.
Okay. All right, we'll keep going unless anybody wants to chime in.
I had a couple questions. I don't know if you can hear me.
Yes, go for it.
Hey, so you mentioned spacing of 40 foot between the chestnuts, but you also mentioned 20, I think, in the beginning. So is sort of the standard the 40 foot, and then this subsoiling and cover cropping would be in that spacing, although this looks narrower, I guess.
Yeah, I can speak to that. So originally, the first plant out that we did in 2018, there was all 40 foot. The trees are going to be 40 to 60 feet at maturity. So 40 foot rows, 40 feet apart. And then we did 20 and 30 feet in the rows.
Okay.
What I decided the next year was to increase the density of a couple blocks within the 7 acres and add a row in at 20 feet. And so the reason to do that is that there'd be more pollen in the field earlier. So that the trees are still pretty small, but they're starting to flower, and with the higher density, they come into production sooner. The downside of that is you spend a lot of time getting those trees up and growing, established, but then within 10 to 15 years, they're needing to be thinned because they're too dense. At 20 foot rows and then 20 or 30 feet within the rows is much denser. And so you'd have a series of thinning out over time. And since these are seedlings primarily, there's a few grafted trees that we're trialing, but they're primarily seedlings, and there's going to be some variability. We would be looking to do selection and taking out the trees that are not as productive or not as high a quality, that kind of thing.
So in this picture, what's the space?
Does that answer
So
your question?
there are more questions coming into the chat that I'll get to here. Lots on cover crops. So is there do you mow, crimp, or till the cover down before planting? Will you be terminating cover crop? Can you just talk a little bit more about the process of?
Yeah, I think what we're going to do is, yes, we'll see what comes through the winter. We'll terminate and we'll sow a late spring cover crop, kind of coordinating. So there's coordinating with Martin over the timing of where the chickens are going to be coming in, making sure that we've got, so we might just leave what's growing in a few areas to let the chickens work that over, and then terminate and start another round of cover crops in another area. So we're kind of playing with it, and there's a certain amount of coordination because there's two different operations, basically two overlapping operations happening. But yes, and I don't have a roller crimper. I have my disc harrow right now for just doing a quick, and we could do a really light till with that, or we would just mow things down with a brush hog.
And a couple comments on deer pressure on both trees and cover crop. What's that look like?
Yeah. Interestingly, down in the valley here, the Connecticut River Valley, it's a big, wide valley with a lot of big tillage agriculture fields, big open fields, and there's not a lot of deer pressure. I think the deer, there's just a lot of open space between the field edges, and so I think there's been more hunting, and it's just a little harder for them to move around and stay safe. So we've had virtually no deer pressure. I had one tree that had a buck rub on it, but I haven't seen a single browse on a tree. So it's a little unusual in that way. So not really an issue. Really, as we mentioned a couple times, the voles, where we have these deep silt soils, the voles, and there's a little bit of a rabbit population. And you can see one of the dogs in that picture there on the right is out hunting, and we've had crows and ravens in the field hunting voles. We've had fox and coyote. We've had a Cooper's hawk. So lots of other animals coming in to help us with some of the pest issues.
And then do you have time for just a couple sourcing questions?
Yeah, sure.
Yeah,
Yep.
So both source of seedlings for the chestnuts, and then also tree tubes sourcing. What kind are you using, and do you like them?
So source for the chestnuts and the tree tubes. So there's a bunch of different growers in the region and outside of the region that are growing really great chestnuts. A lot of these trees came from the Route 9 Collective in Ohio. Some of them from Akiva Silver Twisted Tree, and also Buzz Fervor Perfect Circle Farm in Vermont. And then there's a few others, but those are kind of the main ones. And there's a lot of really great nurseries getting in and doing selection, and contact me, I think, for some additional resources. And the tubes that we're using are Plantra, Plantra, and they're a little bit high end. They're a little bit expensive. I think it's close to, I think it's about $8 a tube. So it's an added expense, definitely cheaper than the wire cages that you can kind of see here, which is welded wire with one T-post. And they seem to be pretty effective, and only maybe one in every 20 or 30 tree gets a little bit of damage from getting messed up with the tube. All right, so we're going to move on. We'll try and catch some more questions. So we'll zoom into the soil health testing. The goal here with the grant is to help fund some pretty intensive monitoring of the conditions in the soil. And so we used a series of different tests. One, not a test, but is just basically our observations of what's going on in the soil and trying to observe changes. We also got Logan Labs tests, which are a pretty good soil chemistry and mineral test, and that's what's on the left here. And then two different protocols, the Cornell CASH protocol, comprehensive assessment of soil health, and NOFA carbon proxy testing, which Kara's going to talk to momentarily. And so the soil chemistry tests are pretty straightforward, and some of the key things that we're seeing here are the organic matter levels are pretty low. The pH is close to 7 in two parts of the field, and then just above 5 in one area. The minerals, as I said before, are pretty balanced with some deficiencies in calcium in one field, calcium, magnesium, and then a deficiency in potassium in two other zones. And then the ratios are a little bit off, but are pretty good. And the micronutrients are also, there's some deficiencies there that we've been working with. The two different sort of testing protocols that we looked at, the Cornell test and NOFA tests, this is a comparison chart to just show what kinds of tests they both had, either in common or separately in physical characteristics, biological and chemical. And you can see that they're both covering though in those areas, but with slightly different testing. So Cornell CASH has a calculation for available water capacity, and NOFA does an in-field water infiltration test. And so similarly, in some of the biological characteristics, there's similar things that are being gotten to try and get to soil organic carbon. Both do an active carbon test, though I think that some of the NOFA, Kara can talk about how things have changed a little bit. But the CASH test is doing organic matter and soil protein. And so overall, let's see, I think I'll go to the next one, but here's a little bit. So we've got comparison between tests to try and see how the different tests are getting information and how they're similar or different. And then we've got comparison between years. And so here in the Logan Labs, the north-south fields, looking at the soil organic matter levels, and we see a even a little bit of a decrease here, but just note that the scale that's a difference between 2.2 and 2.7. So it's really not a big, that's actually within the variability of the testing that we're taking, these kinds of differences that we're seeing. So we're seeing little differences, and I think we'd have to keep taking it, which we are, to see if they're actually trends or if it's staying pretty much the same. But we haven't, I think the gist of this is haven't seen changes in the 3 years substantially in organic matter. The cation exchange capacity, which is a measure of how much the soil is holding cations and the ability of the soil to hold those particular nutrients like calcium, magnesium, sodium, and potassium, and possibly a little change from year 1 and a drop. We don't know whether that's because of the practices and the going from a fallow field to a more actively managed field, or whether that's just within the testing variants. So I think that I'm passing this off then. So I'm going to get out of this a little bit on the pest control. There's some dog vole activity and the Cooper's hawk in the middle. And Caro, I'm going to let you
Sure.
share now and pass it off to you. Keep going with the soil testing work.
Great. All right. So can you all see that?
Yes.
So I just dropped in the chat a link to a folder with some of our soil health assessment or carbon proxy test resources. So if you'd like to follow along with any of the tests that I'm going to talk about, the best document to open is actually our technical protocols, but you'll notice that in that folder, there's also a sort of a DIY grower friendly protocols as well. So yeah, as Jonah mentioned, I should say who I am. I'm Caro Roselle. I'm the Education Director and Soil Health Initiatives Manager for NOFA Mass, the Northeast Organic Farming Association. And we've been so excited to be partnered with Jonah on this grant and to be working with Martin a bit as well. And so I'm going to basically say a little bit about what we're doing, or what our goals are with the carbon test more broadly, and then I'll explain a little bit about what we've observed at Big River Chestnuts. So the NOFA carbon proxy tests, or our soil health assessment approach, is really designed, what we're trying to do is to use physical observations of the soils to basically give a proxy for the soil life, soil health, soil biodiversity, or soil carbon holding capacity of the soil, because all of these different things are related to each other and can be considered proxies for each other. Because soil carbon itself is very hard to directly measure without expensive verification methods, our interest is in really developing a set of field assessment methods that are accessible for farmers to do themselves. And also to provide a technical version of that series of protocols that we do as staff members as a form of technical assistance for farmers who are too busy to do it themselves or don't have all the materials for it. And really through these assessments that we do, we can really help to identify opportunities for and constraints to soil carbon storage or soil biodiversity and soil functioning. So these are the tests that we are currently doing when we do a technical protocol or a technical assessment for a farmer. Jonah mentioned that they have changed a bit. We used to do a soil respiration test, but we stopped doing that after reading technical guidance from NRCS. We also have switched from an aggregate stability protocol that involved wetting the soil, pushing it through a sieve, drying it, submerging it in a Calgon solution, a detergent solution, a bunch of other things. Now we just do a simple slake test. So one of the things we've been doing over the years is looking at what NRCS is putting out for NRCS's field assessments for soil health, and then adapting our protocols to follow in line with what they're doing and be as similar as possible, because they're really the leaders on this. So many of our tests that we do are drawn from NRCS directly from their protocols. So I'm not going to go over all of these tests, but I'm just going to highlight a few of them and talk about what we saw at Big River Chestnuts. So the first thing that we do when we get to a farmer's field is do a surface biology assessment after we've selected a spot to test. With Jono's farm, what we're doing is looking at, we're hoping to see change over time. So we're doing tracking changes over time. So we do identify an area to test and we stay pretty close to that area. And then what we do is the first thing we do is put a hoop down that provides a 30 inch diameter so that we can do some estimations of soil cover. What we're doing is recording what percentage of the soil is actually covered. So often in an annual vegetable farm, the day that we're doing the tests, there might be quite a bit of bare soil showing. Of course, with Big River chestnuts, there's almost always been 100% soil cover, which is great. So we'll just record, what percent of the soil is covered in mulch, what percentage in residue, what percentage in living plants. If there's a plastic mulch down, we'll record that, and then we'll record the percentage of bare soil. We're also going to record whether there is any crusting on the surface of the soil in the case of bare soil, if there's ponding, which we've never seen in Massachusetts, if there is any sign of animals activity. So when we come behind Martin's chickens, we would note if we saw feathers or chicken droppings. I've seen, rodent activity before. We note insect life that's happening on the surface of the soil, mushrooms, mycelia, things like that. And we'll also take a note of how healthy the plant looks. So if we see any discoloration or problems with the plant growth, we'll take a note of that as well. And what's important about this test is not just to sort of record how well the soil is covered, but also to give a context to the rest of the tests that we're about to do. We really want to be looking at what's happening below the surface in context of what's happening on the surface of the soil. So I have to, what's different about this site is we have this, turn off the volume, sorry, won't let me do that permanently. So we'll just play this little video while I'm explaining our digging a hole protocol. So the next thing we do is we dig a cubic foot of soil out of the hole and put it in a bin. We're going to count the earthworms in that cubic foot of soil a little later. And then we go ahead and we take a very close look at the structure of the soil. So we follow the NRCS protocols. And again, if you're following along in the booklet of protocols I sent out, you'll be able to see a simplified chart of these aggregation classification system that we use. But we're following NRCS's procedure here. And what we're doing is looking at classifying the shape of the aggregates that we see, the prevalence of those aggregates, and the size of those aggregates at the top 4 inches, 4 to 8 inches, and 8 to 12 inches. And you can see here in the little video that Jono took of me looking at his soil, we have some really good soil structure at the top 4 inches. There's really a noticeable spot where the mulch layer becomes the soil, and we have a darker colored soil in there. And then we get into some, in the next slide, you can see we get into some more massive soil a little lower down. You can see that there's more surface area and more aggregation, more structure and porosity generally at the top 4 inches of the soil. And then as we get down a little farther, you do see that there's less pore space, right, lower in the soil. So that picture on the right-hand side is below 8 inches in the hole that we dug. On the left-hand side is the top 4 inches. And you can see that's just a close-up of that mulch layer transitioning into the soil. And you can see that there's more pore space and openness and structure there. Another thing that we look at is root behavior, as well as root depth and rhizosheathing. So this was really interesting. Again, we had noticed that there was, at about 4 inches, we lost some structure when we were looking at the soil. And then we saw these thistle roots that at 4 inches, and one of the times that I was out there testing, had this balling behavior. So a lot of times if a root will suddenly make a sharp turn or ball up, that's an indicator that there's an issue at that point in the soil. And so this was on the north field, and you can see in some of my notes that I copied into this slide here. On the north field, we did see a majority of the roots that we looked at terminated at 4 inches in the hole. So there's another indicator. So 4 inches, there's something going on. There's a change in the soil structure. On the south side, we generally saw a little bit deeper roots. I should mention this is a silt loam that we're working with, and the topsoil is at least 12 inches deep. We only dig down to 12 inches, so we don't know when it fully transitions to subsoil. But the topsoil is generally a light brown color and fairly consistent in color. And then we look at biopores and earthworm count as well as part of those tests. So here I have some of my data from that. A biopore is kind of an earthworm channel or a channel left by a root. In this picture, you have a nice close-up of some of the surface, top 4 inches soil there, and you can see that really large, like nice large biopore close to Jonah's pinky there. And so we do count biopores. That's something we did start doing in 2020, so we don't have data from 2018 or 2019 on that. And then you can see our earthworm counts here, fairly steady. Biopore activity, we did find more of it in the test location that we looked at in October versus June. So either that's just soil test location variability, or it's that there was more activity after the rains returned, because we did have a drought this year. And earthworms may have come up from lower in the soil and were more active. And we also note, earthworm eggs. I didn't have room for this picture on the previous slide, but you can see this great picture of this little earthworm egg here. Just wanted to show you all that. So we will note if we found earthworm eggs in the soil as well. But this is mainly about infiltration. So infiltration is another thing we tested, as Jonna mentioned earlier. We use a simple 6-inch section of sewer pipe cut to a standard length and then sharpened on one side, and then we just pound that into the soil. We put a plastic saran wrap over that, fill it with 444 milliliters of water to simulate 1 inch of water, and then in that diameter tube, and then pull out the plastic and then time it. So we record the number of seconds that it takes for that water to infiltrate into the soil. As you can see here from this data pretty clearly, we've been looking at the south side of Big River chestnuts for a little longer, for 2 years longer than we've been looking at the north side. But the first year we did an infiltration test in 2018, we had a very long infiltration rate. It's been a little bit better since then, but you can see from this data here that we had longer infiltration rates in June than we did in October. That is something that we pretty consistently see across the data that we've collected on farms, is that in drought years, infiltration tends to be slower because when the soil dries out, it takes a little bit longer for infiltration, for water infiltration to happen into the soil because of hydrophobia. Slake test is another test we performed. Again, this was added in 2020, replacing a kind of more cumbersome aggregate stability protocol that we weren't crazy about. And so a simple slake test is just a really fantastic test. It helps you get a sense of how much your soil structure holds up to water, sort of overland flooding or heavy precipitation events, how much it resists being broken apart and becoming sort of mud or runoff or erosion. So this test is accomplished by just taking a sample of the soil, placing it in a basket inside of a cylinder filled with water. We use 1/8 inch hardware cloth as our basket, and a simple ball jar as our cylinder, because we don't have scientific cylinders at NOFA. And we record after 1 minute what percentage, based on a visual assessment of the soil removed and placed on a surface, what percentage of that volume of that sample remain in the basket. And we also then look at the cloudiness of the water. But to start with the percentage of the sample that resists falling apart, you can see here from the data that we had 85% of the North Field sample stay in the basket in June, 90% in October, and then 90% both times in the South Field. Again, this is just a visual assessment. We're not drying it and weighing it. And then interestingly, we also did a sort of a control with just using like the edge of the field, just a bunch of sumac trees, collected a sample from underneath there, just to compare that to the treatment areas, which were basically right in the tree rows that Jonna was planted. And only 65% of that sample held on and didn't fall to the bottom of the jar. And then this is in beta testing, but for the muddiness or murkiness of the water, which normally is just a visual assessment, oh, that's murky, that's clear. We're trying out this year using this tool called a Secchi tube, which is, there's a picture of one on the side here. It's a tool used by folks who do water quality analysis to just sort of get a sense of the murkiness or turbidity of the water. So we have one of these. The difference with ours is that the disc, which is that black and white pattern disc, is fixed to the bottom of our tube. I'm not sure why it's movable in this one. So ours is slightly different, but it's about that size. And what we do is after we've removed the sample from the top of the cylinder or jar, we pour it into the Setchi tube while looking at the bottom of the tube at the disc. And the moment at which the disc becomes invisible is we record the number of centimeters of water it took to get there. So you can see that we actually had results that were clearer water in October than we did in June. Again, could be just variability of the particular test site, but I thought that was kind of interesting. And then the lowest amount of water before the disc was obscured. So the highest turbidity was the sumac grove that was not a treatment area. So I thought that was kind of interesting. So what are we learning here? You know, really, when we do a technical assessment for a grower, we provide all the data that we've collected and analysis and some recommendations. And, you know, we're mostly working with organic vegetable growers at NOFA. And really, from our perspective, Jono is doing really everything that we would have recommended to a vegetable grower, such as, you know, using perennials or integrating them. Really, for him, it's all perennials. Keeping the soil covered with living plants as much as possible, maximizing biodiversity, you know, spraying nutrients, leaving residues when mowing, addressing the structure and compaction issues. So in that sense, it's been really interesting to work with Jono. We did notice, you know, what we have ID'd throughout our testing were compaction and structural issues above 4 inches, or sorry, below 4 inches as the primary issues here. This is a lower organic matter soil, but it seems like a lot of the regeneration through Jono's practices are happening at that top 4 inches. So, you know, what to do with the sort of history of kind of soil degradation from intensive tillage from the practices that happened before Jono got there, below 4 inches, how to address that. So subsoiling was something that we had recommended to help open up some of those deeper parts of the soil where the trees themselves and some of the cover cropping that's happening might not be getting that far down to open up those soil layers and just accelerate some of that loosening process. I continue to think that intervening both biologically and mechanically to open up that soil structure is going to be helpful in restoring the soil, combined with all the practices that Jono is doing, such as keeping the soil covered with living plants and adding organic matter to the land. I did have understood from my conversations with Jono that a really high priority and goal for Big River chestnuts is not just to grow a chestnut crop and these related crops, but really to restore the soil and see what's possible around soil restoration. And part of that is really bringing up that organic matter and kind of revving up the engine of the biology on this land, right? And so one of the methods that he's using is this chop and drop method. So really soil digestion is a big part of kind of the goal and the interest I think that Jono has expressed in this piece of land. So one thing that we've brought up as a hypothesis or something to explore is this idea that in this drought year, we did see a depression in a lot of the soil health indicators, not just at Big River chestnuts, but at really all of the other farms that we looked at as well. There were lower earthworm counts, lower, slower infiltration rates. We even saw poorer soil structure on farms that we've looked at for many years in a row during the drought. So we know the soil health literature generally agrees that poor soil moisture does limit decomposition and respiration and other sort of digestive aspects of the soil and life in the soil. So it is kind of raising this question about whether someone like Jono, who's already implemented all of these fantastic soil health practices, whether irrigation actually targeting soil moisture for the sake of the biology of the soil, not just the plants, might be something to consider exploring. So that is something we've been discussing. Mm-hmm. And I also just wanted to note that for our purposes, the SARE grant has been really fantastic because it isn't always the case at NOFA where we do a carbon proxy test at the same time as we get to look at lab results. Some of our grant projects have enabled us to do that. And so Jono's results for his soil carbon proxy test alongside the lab results that he's given me access to will go into our larger database, where we can then look at what correlations we're seeing as an organization around our soil health indicators that we're collecting and lab results like organic matter and cation exchange capacity. So this is just an example of a little scatter plot from an MDAR project we did, looking at 6 growers across 3 years, and we were able to sort of see what correlations there were, for instance, just within our own bulk density analysis and their organic matter. And then finally, I just wanted to remind you that I did drop a link into the chat with a folder of resources, and I really do encourage you to just get out there, especially with the grower version of the manual that offers some interpretations and some handy data sheets, worksheets, so you can fill it out yourself. And just like, you know, try some of them. Get to know your own soil. It's really helpful, I think, for any of us who are growing on soil to just get to know our own soil. And these data sheets will give you a way to start keeping records of what you're seeing on your own land. So I think it can be a great learning tool. If you have any questions about it, feel free to reach out to me.
Great.
Oh, and here's my cute transition slide of Cricket, Jono's puppy.
Doing some soil testing and vole hunting at the same time.
She's got soil on her nose. She's been investigating.
Yes.
Taste testing.
Indeed. Great. Thank you, Kara. That's great. That's really, and one thought that I have from what you've covered and what we've been talking about is the challenges of documenting changes in field conditions and the soil conditions. There's a lot of work on how to do this in annual cropping, and I think there's less in a perennial cropping, tree cropping situation. And so, trying to identify both what changes are happening and why they might be happening. And we kind of mentioned at the beginning, part of this, the grant is also to look at carbon sequestration. And we haven't really, the parameters haven't really shifted. The carbon levels haven't really shifted in the first 3 years, 3 growing seasons. So, but that's not, from our look at other data, that's not that unusual, that it's going to take some more time as we get the sort of the whole system going. So we have time for questions, some more questions, but I guess maybe for Martin or Caro, any other thoughts on kind of summary thoughts on what we've learned or what kind of changes that we have seen or haven't seen?
Martin, I don't know if you have anything to share, but generally I think that we see some, in my data, I see some soil health indicators being a little bit higher on the north side of the field versus the south side, and on the south side versus the north side. Like I mentioned, there's a little bit deeper roots, average root termination on the south side. At this point, the data we've collected is so small and it's over so few years that it's hard to say whether that has anything to do with the chickens or not. But I think it points to there's a lot of value here to keep collecting this data on your site, Jono, to see what kinds of improvements we can see in both soil organic matter, cation exchange capacity, but also some of these physical indicators over a longer period of time, especially since there's this opportunity to see what impact the chickens have in the ecosystem since you're constraining them to one side of the farm.
Yeah.
As far as the soil goes, we really do just have to continue on to see what the effects are. I've raised chickens in a lot of different situations now. And I can very easily say that the diversity that's in this field is producing some really excellent quality meat compared to what I've done in the past. And there was one indicator that I think was caused by the higher clay content combined with the drought this summer. The chickens there got, most of the chickens there got blisters on their feet. But I was processing, I was the also the slaughtering specialist at the processing unit in Sunderland that just opened last year, Reed Farm Processing for anybody who's interested. But the majority of the pastured chickens that went through that unit also had these blisters. So, but at the second half of the year, the chickens that came out of the pasture at Jono's stopped having those blisters, whereas other pastured operations continued to have the blisters. So I'm just wondering, it's not, again, it's a long-term observation, but it seems that something about the soil quality changed throughout the summer that reduced whatever was causing that blister in the chickens at Big River Chestnuts, but not anywhere else. So
Great. Yeah, good observation. Something for us to keep our eye out for. So we've got a few more minutes. So we go through and look at questions. Do you want to, Genevieve, you want to identify questions? And
Yeah, there have been some more questions. If there are any related to Caro's piece, feel free to just start typing them in. There are some left over from the previous one. And I think, Sorrel, I know you asked about processing, but if you had any follow-up questions about chicken processing, feel free to type that in. There was a question about why did you make the management decision to use the subsoiler? Were there specific problems that your other kind of planting management plan weren't working?
that's a good question. You know, because we have the trees are there, the shrubs, the small fruit, as well as the regrowth in the field is a lot of saplings and trees, and so those are definitely getting into those compacted layers and breaking it up. And so I think it's what Caro said is basically just accelerating that process. The subsoiler is pretty easy to operate. It's not too disruptive in the soil. You know, it took us probably an afternoon to run the lines that we did, and then come along and break it up and smooth it up a little bit with the disc harrow. Was another half a day. So it's mostly to accelerate that that breaking up of the compacted layer, and increasing that infiltration and soil building activity.
There's another question about whether you tilled the strips before planting chestnuts, or if they all went right into the ground.
Yeah, we didn't. The site prep ahead of time was pretty fast because we were racing of how these things go. Ideally, you know, we'd have more time, do a year of site prep, but we basically cut the rows manually. I didn't even have access to the brush hog at that point, and that we were borrowing, and so we pretty much just cut the rows, left the brushy growth in between the rows to continue to grow, and that's what we've been doing that short rotation woody coppice with, and just basically planting right into what was a 5-year fallow field, put the trees right in, and then kind of slowly transitioning the zones over into more open field characteristics.
And a little bit about pruning. Can you talk a little bit more about your pruning strategy over the now and then moving forward?
Yeah, little trees don't get pruned very much. We try and let them go as much as possible. I've done very little for the first 2 winters. This year we'll start to prune a bit for shape and for some characteristics of the branching to try and get a strong branch pattern going. So yeah, the chestnuts are not like fruit trees that need a lot of pruning. You're just doing some shaping, and then they won't need to be pruned for size at all in the open field. Though interestingly, we have a section of the field I didn't get into that's up against the neighbor's Riverland farm, and they have a greenhouse. And so I've planted some trees right on the property line, but I don't want to shade. I don't want to be growing 50, 60-foot trees next to their greenhouse. So we're going to try a fairly intensive pruning method. I've been watching what they do in Japan, growing chestnuts with a very intensive pruning system, very Japanese style. And so we'll probably do that. We've got a couple rows over there, and we'll just practice with different, more intensive pruning.
Sorry, I was delaying my unmuting because my daughter is talking to me. So Martin, quick question for you. Someone asking if you made any observations about if there was a link between plants that were either in bloom or in abundance and the chicken blisters potentially.
No. So Jono at that time was not doing any planting inside of the paddocks where I had the chickens. There was some question about, could stubble from woody plants be damaging the foot pads and causing blisters that way? But the stubble, my observation was that the stubble was no different between the chickens that were getting blisters and that weren't. To my knowledge, it was not the plant types. Whether or not it was something that was flowering, I'm not sure. It's going to require another couple seasons of observations to really establish a pattern.
Great, thanks, Martin. I would, looking at the time, I think we probably have time for one more, and then just sort of maybe, Jono, if you have a wrap up and a way people can get in touch with you or keep engaged. And I'll also save a file of the chat for folks to read through in case they missed anything. Kate Parsons is asking, is vegetation managed in the 3-foot zone around the trees actively, or what's the management there?
Yeah, that's a good question. Yes, during establishment for the first couple of years, we want to reduce the competition right around the tree. It's that really the first 2 to 3 years. Though I have been watching a grower, I think in Pennsylvania, who's done almost no weed management or grass management around the trees, and they seem to be doing fine. But the data typically shows that trees don't want competition right around them as they get established. So we've done wood chip mulch or wood chip on top of cardboard and newspaper mulch. That's where we got in trouble with the voles, where the voles were burrowing and nesting in there. And then as winter came, it kind of, it reduced the freezing in the fall. And so they basically were burrowing in under right around the trees, and they were chewing off the trees below our vole protection. We have different kinds of tubes or hardware cloth that go in 1 inch or 2, but the voles were actually chewing the trees off 3 to 4 inches underground and completely reducing their ability to resprout. So yes, and we've also done, in addition to some mulching and just some hand weeding, to also trialing some paper barriers that really just need to be able to last a year to 2 years for that establishment period. Okay, so I think I'm going to add in here my email. So in case folks, we didn't get to all the questions. Most people have my contact info, or but there's my email in the chat. And you have, I think Caro and Martin both put theirs in as well. So feel free to follow up with us with other questions or resources. Really appreciate everybody coming today. It's been really fun to share about what we've been doing. The project's a long-term project, obviously, and we really hope people will come out to the farm this coming year. We'll send some messages out through the same channels when we do some field days, and have a chance to walk around by the river, see the trees growing, see the chickens, and yeah, really appreciate it, and appreciate Martin, and working with him has been really great, and Caro too. Thank you for all of your efforts, and there's been a lot of people involved, and so really this is a big team effort here and a long-term effort. So yay.